Next we talk about equivalent norms. Okay, equivalent norms. So two norms, norm 1 and norm 2 on a vector space. Two norms norm 1 and norm 2 on a vector space V. Two norms on a vector space V are equivalent if the matrices induced by them are equivalent. If the matrices are induced by them are equivalent. Okay, here another way we write this: the norms are equivalent. The norms are equivalent if and only if there exists positive constant, there exists C1 C2 greater than 0 constants such that C1 norm x1 less than equal to norm x2 less than equal to C2 norm x1. Okay, x belongs to V. Then we also discuss about these things. That means if P101 is open, then there exists R greater than 0. If P101 is open, then there exists R greater than 0, such that B20 are subset of B101. Okay, and if x if 0 not equal to x, then norm of Rx by 2 norm x2 equal to R by 2 less than R. Okay, and y belongs to, so y belongs to, hence y belongs to B101. Okay, normal bar, hence y equal to Rx by 2 norm of x2 belongs to B101, and that is norm of Rx by 2 norm x2 less than equal to 1, or this implies that, or R by 2 norm x1 less than equal to norm x2 for all x. Okay, thus we may take C1 equal to R by 2. If C1 equal to R by 2, then obviously we see that, then with this argument we see that c1 norm x1 less than equal to norm x2. Okay, and in converse way we also erase these four sums. In converse we discuss converse we discuss let b1 b1 0 r1 b1 0 r1 subset of b2 0 1. Okay, and this way this one and b2 obviously b2 0 0 r2 subset of b1 0 1. Okay, then this implies that implies this one by these things we're getting this required result. That means norm of x2 less than equal to c2 norm of x1. Okay, how we obtain this? We obtain in similar way if we replace these things x1, this b20r b10r, then this one is same thing done by this thing. Okay, just norm of x2 here. That means y considered rx by 2 norm of x1, then this one is happen. Okay, that means if we considered rx by 2 norm x norm 1 equal to less than r, or that means we consider these things here. If x not equal to 0, then x not equal to 0, then rx by 2 norm x1 norm of x1 1 equal to r by 2 less than r. Okay, then z equal to rx by 2 norm x1 less than or belongs to b201. Okay, then these things obviously we write about that norm of rx by 2 norm of x1 less than 1. This implies norm of x, this implies that norm of, here we write norm of x2. Okay, here we write norm of x2. Then this one is norm of x2 less than equal to 2 by r norm of x1. Okay, then we construct similar way this thing x2 subset of c2 x1. Then obviously we get this result. C1 norm x1 less than equal to norm x2 less than equal to C2 norm x1. Okay, then two norms are equivalent. Next we proceed further and discuss the problem. Discuss next problem. This one is the we start about these things. We write this the norms, norm 1, norm 2, norm infinity on Rn are equivalent. On Rn are equivalent. Okay, or more precisely we show that 1 by n norm of x1 less than equal to 1 by norm n norm of x2 or less than equal to norm of x infinity less than equal to norm of x2 less than equal to norm of x1. How we write, or all norms in Rn are equivalent. Okay, we just write about it. If x equal to norm of x1 norm of x2 dot norm of xn, okay, in Rn, and 1 dot 1 belongs to Rn, then we write these things. Summation norm of xi I equal to 1 to n less than equal to summation I equal to 1 to n multiplied by summation norm of xi square I equal to 1 to n. Okay, whole to the power half. Then this one equal to, this implies that summation I equal to 1 to n norm of xi less than equal to n square root of norm of xi square I equal to 1 to n whole to the power half. Okay, then this one is, this implies that 1 by n norm of I equal to 1 to n xi less than equal to 1 by root n norm of xi square whole to the power half 1 to n. This implies that 1 by n norm x1 less than equal to 1 by root n norm x2. Okay, then these two norms are equivalent. Okay, in this way. And next we see about that means we use here Cauchy-Schwarz inequality. Okay, next we see about that this thing, that means this one equal to less than equal to norm infinity. Okay, that means we see about that norm infinity equal to supremum of xt when t belongs to, when x, supremum of x, function of x or x in here, when supremum of x such that supremum of x in where x equal to x in, that means supremum of x. Okay, and this one less than equal to, and norm x2 equal to, norm x2 equal to summation I equal to 1 to n xi square whole to the power half, and norm x1 equal to, okay, and norm x1 equal to summation I equal to 1 to n xi, norm of xi, here supremum of xn. Okay, norm of x infinity equal to this one, norm of x infinity equal to supremum or maximum of xk. Okay, k equal to 1 to n, that means supremum of or maximum of xk where 1 less than equal to k less than equal to n. Okay, then we see about that this one equal to this one, that means norm of x infinity less than equal to norm x2 and less than equal to norm x1. Okay, so today we stop here.